Hello everyone. So today what I'm going to discuss is the three types of plate boundaries. So I'm going to be taking my screen off here in just a second. It's a little bit longer than the most, so that's why I'm going to go ahead and pre-record it. It might have to be in two videos, but I think you'll be okay. I will give time for pausing and stopping, but if you guys are finding that it is not long enough, um, please let me know, or just go ahead and stop the video and you guys are able to complete it. Okay? All right. So I'm going to go ahead and get started. What you'll need is your plate tectonic one. If you do not have that, go ahead and put it in the email me or put it in the chat because this will be during class and I will send it to you. Okay? Remember, you're going to be doing this as along with me. So just understand that. Now we have gone over the um, the three types, but we haven't gone into depth with them. Okay? All right. So I'm going to be doing a little bit of it, but majority of it is going to be on your end. Okay? So I'm going to go over topic 4 and then maybe 5, but most likely 4. So I'm on slide 5 for you guys, topic 4. So what are plate boundaries? Okay, that will go right here. That's the topic question. Plate boundaries are where the tectonic plates blank. They are blank ways to blank, or two plates can move blank together. So plate boundaries are where tectonic plates meet. There are three ways that two plates can move relative to each other. Now, relative's the right word because I was thinking that they were going to use a different word. And relative just meaning that they're not brother and sister, that they're just related to, or that they're somehow functional towards each other. Okay, let me go ahead and zoom in so you can see where that goes. Okay, alrighty. Okay, so the first one that we're going to talk about is the transform boundaries. Okay, I paused it for just a second just to make sure that you guys could see. Now, if you notice that we've already gone over very, very quickly this, but I just want to make sure that we are understanding it. So if you notice that the transform, we have two plates. So those are just represented by the squares. Remember, there's an insurmountable amount of matter that is going on with that. So we have an arrow pointing down and an arrow pointing up. At transform boundaries, plates slide past each other and the lithosphere is neither created or destroyed. Remember, that's the crust. What that means, I'll let you have time to type. Okay, so, and again, the nifty thing is if you need more time, pause it. So converge, diverge, transform, San Andreas. Okay, converge, diverge, transform, San Andreas. All right, and I say that because it's a little thing that you can have that you can remember the three. All right, it's neither created nor destroyed. Now, what that means is that it doesn't destroy buildings or not. That's not the topic. The crust itself is neither having new structure put in or it's reducing the other one. And that will make sense on the next couple types of boundaries. So with transform, I said a specific fault line. That's pretty common. You guys might know that from Grand Theft Auto. This creates friction and stress, which causes earthquakes. Okay, not tiny earthquakes. These are pretty gnarly earthquakes, and that's what we'll get into. Friction is heat, and stress, just kind of like if you guys have too much stress going on, there's a breaking point. Okay. And San Andreas. So the transform one. Now trans means in between, so it's in between forms. Okay. The San Andreas Fault is a transform boundary, why there's so many earthquakes there. On the video beforehand, I'm going to go ahead and move down a slide. It's basically, if you see, it's the Pacific plate moving past the North American plate. Okay. All right. Okay. The next boundary is divergent. So that will go on the next slide right here. Okay. The topic question is continued because we're still on topic 4. So divergent boundaries. So you would be clicking right here. If you notice that the arrows are pointing opposite of each other. So transform was going this way. Divergent is pointing opposite. They're almost on the same axes. If you also notice here that there's a little plume going here and a ridge. So the lithosphere is the top part, that asthenosphere is that part, upper part of that mantle. Okay? So they're separating basically on the same axes. And let me show you where this goes. It goes right there. Okay? At a divergent boundary, plates move away from each other. Magma from within the earth and fills the gaps. Magma we have not talked about. It's basically in molten rock that's inside the earth. Lava's outside the earth. Okay. So if you notice, there's the convection current going right here, a little plume, and the mid-ocean ridge, and an oceanic crust going to each side. Now, they did symbolize that a little bit different than the continental crust. Okay, that's pretty important. When this happens at the boundaries, so we're specifically talking about the ocean surface, and this will go okay in the ocean, just so that you guys can see where it goes. Ocean, the new magma, just to show, gave not very much time. The new magma creates a new seafloor. The Mid-Atlantic Ridge and the East Pacific Ridge are mid-ocean ridges where the seafloor spreading occurs. And we simulated this because the older crust goes out here and it has a different magnetic pull. Okay. And we're going back to one of my favorite places in the world, those black sands of Iceland. And where those black sands occur are right around here in a place called Vik. Okay, got Reykjavik, which is the capital, but there's a place called Vik, not Rick, Vik. Okay. The divergent boundary in the middle of the continent rift valleys, the East African rift, is an example of, and that I'll show you a copy of that. This is not the East African plate. There's the North American plate and the Eurasian plate. So Canadian geese right in the middle don't know where they're going. Okay, a divergent boundary in the middle of the continents from the rift valleys, East African rift, is an example of that. And I'll show you guys an image of that. That is down by in the Red Sea. I believe it's the Red Sea, but it's separating a subcontinent and a continent. Okay, the island of Iceland sits atop a divergent plate boundary between North America and the Eurasian plates. You can scuba dive, and we showed a video of that. Reminder that Iceland is on the 62nd parallel, so it's really high up, close to the Arctic Circle, but it has a tremendous amount of volcanoes. One of the highest, I think Italy does beat it, but it has, but they have some volcanoes they're not for sure, or they don't know quite how many. Okay, the last one is Convergent. Now, we did not read about this in CK12. Okay, so if you notice that one is going underneath the other here, and we're producing some volcanoes. So at convergent boundaries, plate moves towards each other and collide. So that will go right here. Now I do have to speed this up a little bit, okay, because I'm limited on time. We did not have a CK12 over plate bound or convergent boundaries, and there's a reason why for that, because there's three types, and we're having continental, oceanic, and then oceanic, okay? And we're coming together. The key word on this is subduction zone, is where one plate is denser than the other. The denser plate sinks underneath the less dense, and the process is called subduction. Subduction comes from the Latin root subdux. All right, I'm going to